Hi, welcome to my next tutorial on Angular 4 series, and in this session we're looking at how to test an Angular app using Jasmine and Karma. So whenever we are developing any kind of application, be it web application or any other kind of application, we need to test it. So sometimes that test is performed manually by a developer, or at times we prefer writing an automated test unit test. Okay. So depending on the project requirement, like how big a project is and what is the deadline of the project, what is the budget of the project, then we decide whether we should go for an automated unit testing or not. Okay, so there are few tools to carry out this testing, like you must have heard about Protector. Then there is Jasmine and Karma. These are the testing frameworks and the test runners. So we will be looking at Jasmine and Karma, which you will get in Angular, which you will already get within your Angular code base once you run the test command from the CLI. So you will be having a look at it in a short while. Before that, let's look at the type of Angular 4 tests, or in fact Angular 2 also. It is compatible with Angular 2 as well. When I mention Angular 4, it is applicable for Angular 2 as well. So the types of test can be categorized as unit test, in which you can test any simple function or a single component in isolation, and this is very fast, but you cannot assure that the entire application would run fine if you are just doing a unit test. So just for a single unit or a single function, you can assure that this will work fine. Next type of category is integration test, where you are testing a component with a template. Okay, the component to template interaction. So this is a little more time consuming as compared with unit test case, but this is very much preferred as well for our Angular application. And next, the third part is end-to-end test, where you are testing the entire application as a whole, including user interaction and service calls. In the first two types, we can only fake, or in integration test we just fake a service call, but here we can actually test a whole application including the actual service calls. But this is very much time consuming, but the advantage is that you can assure that your application works fine after this test has passed. Okay, now quickly moving to Angular code base. So I will create a new, say, Angular project by giving the command, say, ng new. So I've already created that project, so I'll just start, right? So I have that project already. So inside Angular 4 directory, I already have that I've created a new project called Angular 4 test demo, and I have just issued a command. If you remember it from one of the previous tutorial, I just have to give ng new Angular test demo. So once I issue this command at this command line and press enter, then it will generate a project file and the whole folder structure for me, which we are already aware of. Okay, so I've already done that so as to save time, because it will take some time to render the project. So straight away come over here, then I will, okay, this is already created, so I don't need to move inside any other directory. Okay, so here I will first run. So once I open this project in Visual Studio Code, you'll see that these default components are already there once you have created a project. Okay, so if you observe, then there is one component called app.component.spec.ts. so any component that has extension .spec.ts, so that is a spec, that is a testing component. All your unit test cases are written over there. Okay, so let's open it. Okay, so you see that this is this test bed and everything, they are imported already. Then you see this describe function is there, and before each, so there are few functions over there. Okay, so we'll discussing it. So before that, let's do one thing. Let us just run, instead of ng serve, let us do ng. After doing, sorry, just missed it out. If you remember, after saying ng new Angular test demo, then you have to give the command ng install. After this, then we generally give ng serve to start the server, but we won't be using this ng serve. Okay, instead of this we will be typing ng test, because we want to run the test script. So ng test. So let's run this. So we already have that. Once you say ng test, it will configure and pull out all the file for Karma, that is the test runner, along with Jasmine testing framework. And you can see in the console, after this has finished executing, you can see it in the console, the result. So this will take some time, so we'll just need to wait for it. Okay. And now finally we have that executed. So once this gets executed, you'll see that this success is the message success comes over here, and it as well opens up the browser also, the report in the browser as well. So here you can see the browser running at port 9876 in this case. Okay, so it is mentioning that the app component, it was successfully executed, means the test has passed. Okay, so if you come over here, so if you just see this, there are few functions called describe, it, expect. So we'll just be doing some of the most significant ones. There are lots many more to learn in testing, but we'll be covering the most essential ones. So we'll just see what they are. So for that, let us do one thing. Let us quickly create a file. Okay, so I'll create a component, say calculator, say dimension calculator. I'll name it dimension calculator .ts. So in this case, what I'll do is I'll just create a class component. I'll just create a class, in fact. So class, say dimension. So dimension calculator. Okay, inside this class we'll have some methods. Say public method I'll write, say I'll write get area. Okay, and here I'll give some length and breadth. So length, say of type number. Okay, then breadth of type number. Sorry, spelling I have to correct. Okay, and then we'll give a return type over here. So return type would be a number, or even I can give, okay, let me give it number only. So here I'll simply have returned length into breadth. Okay, as simple as this. Now before we write a test case for this, first let us understand the structure of a test case, codes that we will write, the functions. So now we go to the next slide. So basically any testing functions that we write, it consists of two functions. One is describe, one is it, and apart from this there are lots many, but these are the basic ones. So describe is just like a test suite. You can have a test suite over here, and within this there can be many specs within a one describe, and it function is the spec or the test. So if you want to write a unit test case for this dimension calculator, so you need to create one file. Say let us name this dimension calculator. The naming convention is that you should have the same name, though not necessary, but you should actually have the same name only with one spec, dot spec provided, because that is the requirement for the naming convention of this testing framework, TS. Okay, so now dimension calculator dot spec dot TS. So here we can write, oh, I've closed it. Okay, here you have to write the describe function. This describe function takes two parameters. First parameter is the string. So here I will mention some meaningful, sentence or words through which we can identify what this test suite is for. So here I write dimension dimension calculator validation or check. Okay, and second parameter will be a function. So instead of this function, let us do one thing. Let us write an arrow function over here. That will be more simpler. Okay, so this is a describe function. Inside describe you can have, describe is a test suite as I mentioned. Inside this you can have many test specs, and test spec is written with using this function it. So inside it function also, say this is the first spec we are writing. I'll write validate area is greater than 100. We'll soon come to this. And next parameter will be a function. So let's give an arrow function over here as well. Okay, so here first we'll write let see, we need to import that dimension calculator component which we have created over here, so that class in fact. So first you need to import it, import, okay, from slash dimension calculator. Okay, so the component name over here is, so I can get an auto suggest now. So that is why I wrote that first, the path first. So this actually helps me in getting the auto suggest for this. The IntelliSense will suggest me. Okay, now I'll say let say dim calc, in short for dimension calculator. Okay, say this is of type dimension calculator equals new dimension calculator. Okay, so first I initialize this, then next I'll write next I'll get the value. Okay, say let this be a constant because this is not going to change because we are just running it for once. So constant, let us say area equals say dim calc dot get area is the method name, and two parameters I have to pass. Say I pass 3 and I pass 9. Okay, now finally we can we have to assert it. So final part is called assertion. So assertion, we write a function called expect. Is a function called expect for assertion. Okay, so these two are the basic functions for spec, but there is one more function called expect. Okay, this is called expect, and this is for assertion. This will assert your test case. Okay, based on this assertion it will pass or fail. So coming back, I'll say expect. Okay, and then the value to be tested, say area, then dot. So here we need to check for equality of greater than, whether it is greater than or less than, to be greater than. So we will say greater than, or say for example let's make it like this. If validate if area is equal to, first let's start with this one. Same way we can do for greater than also. So it will be toBe. If I have to check for equality, then we have to write toBe 100. So only if it is 100, then the test will pass, otherwise it will fail. So in our case, what is it? It is 27. 3 and 9, 3 9s are 27, so the test will fail. So let us see. So we don't need to recompile it, so automatically it will watch the change, detect the change, and see it is giving failed. Even if we come to this browser, it will show fail. Calculator validation is equal than 100, so it is red in color. This means it has failed. Okay, now to make this test pass, suppose in our application we expect the outcome that the calculation area should be 100, so this way we can test it. Now say for example I have given some value, say this is 20 and this is 5, so this time it will be 100, and so the test should pass. So now let's see. So it is executing. So after it finishes the executing, it will generate the report. Okay, there seems to be a mistake. I think we have made a mistake out here. This should be capital D first of all, and now if I go to this dimension calculator.ts, I have forgotten to export this class, so it won't be visible. That's why this is failing. Export class. So I think it should be fine now. Okay, now let us check it. So it is 100. The test should pass now. Okay, so the test has passed. It is showing success. So if I open this, I see that it passes the test. Okay, it is equal to greater validation is equal to 100. Okay, validator. Okay, the statement I have written very not properly, so not an issue. We can just change it. Validation. Validate that the value that area is so that is just a typing mistake. Area is equal to 100, not greater than, equal to 100. Okay, so it will show the report that way only. So this is quite simple. Okay, so same way, say if I come to the same dimension calculator, and then I can go on writing another method. Say I've got a different method, say public, and though this is a dimension calculator, or okay, let me do one thing. Let me take a different okay, let me first write get volume. So same way, if I have to write volume, or say get perimeter, for example, get perimeter. Say this is a circle, not a circle. Say let us keep it simple, let us take a rectangle, for example. So get perimeter, and then I'll have same way, I'll have length comma number, then breadth comma number. Okay, and the return type should be a number. So I'll say return. So what is the formula for perimeter? Twice into length. Okay, it is 2 length plus 2 breadth, twice into length plus twice into breadth. So simply I can write twice into length plus breadth. This way also I can write, taking the common term. Okay, so I can write a spec for this as well. Okay, so same way I can write it. I'll just copy this, I'll just paste this. Okay, so here I'll write validate. Okay, so please excuse my spelling mistake. I do a lot of spelling mistake. Okay, validate that perimeter. Okay, is here we will check for greater than 100. Okay, so if I just leave it as it is, okay, just I have to say get perimeter, and instead of area, let me make it perimeter. Okay, so this is very much similar to what we have done here. Still, let us check it out. So it is getting executed, and so let's see if this entire test suite passes or fails. It fails. Why it fails? Because here it is not valid. So if I just come over here, so it shows what has failed. It will show you the perimeter is greater than 100. That condition is not valid. So if I say, so if I give some value, say 75 and 20. Now let us see. So this is executing. So first one is valid, second one is also valid now. So the test should pass. That is what we anticipate. Okay. Okay, still it is failing. Okay, the reason is that we are still taking toBe function. I have to take, this is the mistake I make. Okay, I have to take greater than, to be greater than. Okay, or equal to just greater than also we can take. So let us see, now it should pass. Even initially it failed just because it was not just equal to 100, that's why it was failing. Okay, now it is a success. Okay, so this test has passed. So this way we can unit test our functions, our classes, even the components also we can test. Okay, whether it is a integration test or a unit test, you can automate it this way just by using describe and it function and expect for assertion. Okay, now let us take one case. Say I take a say counter component. Okay, so there is a component called counter.ts, a very simple component. Okay, inside this counter component I'll say export class counter say component. Okay, and this will have two methods. So first it will have public say counter is equal to the value of the counter is by default let us keep it as 0, so it will be a number. So here by default it will be a 0, and we will have two function public increment counter, so increment counter, and this should so return type I'll make it void, so this should just say counter plus plus. Okay, okay, what it is saying, cannot find the name counter. Okay, this dot counter, sorry, I have forgotten to actually I have to keep switching the context between different libraries. Okay, so same way I'll make a decrement counter, a function called decrement. Instead of increment I'll write decrement counter, and instead of plus plus this will be minus minus. Okay, okay, now let us write a test spec for this counter. So what I'll do, same process I'll follow. I'll just take counter dot spec dot ts. Okay, so here I'll write describe. First I'll import the counter component, import counter component. Okay, from counter. Okay, and then we can write the describe function, describe. Okay, so here validate counter will be the label for the suit, and then the function and then the arrow function we give, and then this function inside it I'll write the specs. So first spec I'm checking for say increment, or I will say check for positive value, say check for positive. Okay, whether this is a positive value or a negative value. Okay, and then we don't want any negative value, so that is why we are checking it. So I'll say expect first I have to say let counter. Okay, so this will be of type counter component is equal to new counter component. Okay, next part will be your invoking the method. Okay, so counter constant say count value is equal to say counter dot increment counter. Okay, so just increment counter, and then finally the assertion expect say count value Okay, expect count value dot, so we are checking for positive, so to be greater than 0. Okay, so this is it. And now if I check it, okay, so initial one is 0, initially counter value is 0, so this test should pass, it should be greater than 1. Okay, it says failed. Let's see why it is failed. To be greater than 0, we already incremented the counter, so if you come to counter.ts, initial value of the counter is 0, so this should be counter plus plus, so this should be plus. Okay, fine. We are actually we have made a silly mistake out here, so we should not check for count value. Sorry, we should check for count value, but first we have to run counter dot increment value. Okay, so this we should run first, and then we should collect the value. We are not collecting because see, increment counter is not returning anything, or other way around, what we can do is just return the value of the counter. Better, return counter, either read this counter or just return counter. So here I have to say return type number. Okay, same way let us do over here also, and let us return counter over here. Sorry, it should be this dot counter. Again I'm making the same mistake, so here also you have to write this dot counter. Okay, now let us come back to this spec and let us just check it now. So now initial value, it is incrementing and now returning the value. Initially there was no value returned. Okay, so now we see it is success. Okay, so the test is success now, so it is saying success. Okay, now let us go back. Okay, same way we'll check for, so I can put us in, let us check for the decrement also. Same way I can check for this for positive, so check for 0. Okay, so check for negative, in fact. So same way I can say that to be less than, to be less than. To be less than 0. If it is decrementing, it will be less than 0. Okay, if it is negative, that means it is less than 0. Okay, now let's see. Okay, this has failed because we haven't changed this to decrement counter. So I make a decrement counter. Now let us see. Okay, so two specs we have written in the same suit. Okay, so it is giving success in both the cases. So in this case it is incrementing from 0 to 1, so it is greater than 0. In this case it is decrementing from 0 to -1, so this also pass, less than 0. So both the case it pass. Now this part, if you observe in this code, you will see there are three parts generally. This is the first part, this is the second part, and this is the third part. So this first part is generally known as, if we come to this slide, let me just discuss it a little. Okay, this is a AAA rule of testing. First part is known as arrange, second part act, where you are invoking the method, and third part is the assert. Okay, so this part will be your arrange part, where you are initializing the component, which component needs to be tested. Okay, second part over here, okay, this part is called act part. Here you are actually acting upon the method, invoking the method or a function. And final part is your assert part, okay, where you are asserting it. Okay, so this is the rule, AAA rule. as it is known. Fine. And then we have some best practice we have to follow. The best practices are that your function name should be very much meaningful. Like here, the labeling which we are giving, name or label, valid, counter, check for positive, it should be okay, so that you can make it out what it is for. Other developers can make it out. Okay, and there should be very few line of code. You should not have too much code, otherwise it is difficult to maintain. And it should handle individual responsibility. One unit test that you are writing, it should handle the individual check for an individual thing. Okay, individual functionality, not multiple functionality. If there are multiple functionality, break it into separate unit test case. Okay. Now as you see that this is redundant, right? This part is redundant. So if there are only few instances, but if there are more instances like this, then that can be a performance issue or a memory issue. So because of that, there is a just to deal with it, there is also another function known as before each, which you can write. So you can write it over here, before each. So there is a before each function. So in this before each function, you can just give the function name, like what is the function you want to give. So you can give an anonymous function, arrow function I mean, or anonymous function also. So here you can do all your initialization. Okay, so this before each will execute every time a new spec is executing. Like in this case, it will execute 2 times, 1 time, 2 time. So I can move this before each over here. So this part, what I can do is I can just move it over here. First I will say let me paste it over here first. Okay, and here there I'll declare it outside the loop, and here I'll simply say counter equals, here I can initialize it. Okay, this way I can do. Okay, so every time I don't have to initialize it, so I can just remove it from here as well. Okay, so now let's run it and see what are the impacts. Okay, so this way we can arrange it, but there can be an impact due to this. So let us first check the test. So in this case the test has passed. Okay, and this increment decrement both are valid now. So this can be an impact. Suppose if your counter that we are using, say if it is a static, instead of this instance variable, say it is a static. Okay, so we need to take care of that. Okay, so this was before each. So each time this counter is actually instantiating to a new instance of this counter component class. So instead of writing so many places, I can just write it in one places. But still, even in this case also, remember that this counter has been is anyway getting initialized at each step. So it hardly makes any difference on the performance as well. So same like before each, we have after each. We won't be using after each over here. This is for cleanup. Like once this every spec has finished executing, then this will get processed. Okay. So here we are not writing anything in after each. So you can try out if you want any kind of cleanup is required, then you can always use after each. Okay. Now, okay, let me remove it. We don't require after each. So same way like before each, we have just let me comment this out first. We have before all and after all. Okay, we have before all, and in this before all we will pass the arrow function same way. Okay, so same way we can pass an function, and this function just like we have written over here, say counter equals new counterpart. So now what is the difference between before all and before each? Before all will execute only once. Okay, before all will execute just once, while before each will execute for each spec, once for each spec. Like here we have got two specs, check for positive and check for negative. So it will execute 2 times, but before all will execute just once. And now in this case, let us run it and see, and we see the test has failed. Okay, so what is the reason for the test to fail? The reason is that now we have got this component only once. Okay, only once. So same component has been incremented over here, it has become +1, and same component over here when decremented it is becoming 1, not negative. In the previous case we were using before each. So just try to understand this concept. So this counter instance of this counter were separate for each spec, but this time it is only one instance. One instance method is only acted upon. So that is why this, in this case this became 1, in this case it becomes 0. Okay, so if I just check for 0, then this will pass, just to validate whether that is what has actually happened. Say I say toBe 0 or toEqual 0, whatever. Now let us see. So you need to be very careful, like when you are choosing the initialization and destruction of the object. See, now it has passed. So you get the concept, like why in the previous case it failed and this previous case it passed and this case it is failing. So same way, before all we write after all. We have this function after all. So here also it will take one arrow function. So here you can do the cleanup. So cleanup we can say something like, say counter is equal to, say null, or you can delete the counter, something like that. Okay, that is giving some error. Okay, there is a arrow missing over here. So you can clean it up like this, after all or after each also you can take. So this is the difference between before all, after all, and before each and after each. So this will, so after, before each and after each can also be mentioned as setup. This process can be called as setup. Before and after all, I mean after each is also known as teardown. Okay, setup and teardown. So these are the terms sometimes used. Okay, fine. Now finally let's see one more part using an array. So what I will do is in counter only, I will just define over here, say an array public, say countries. Okay, say this is of type array. Okay, having of type string. Okay, is equal to say first one is India, or let me write all in capital only, India. Say second one is USA, third one is say Japan, okay, and let me take one more, say this is say France. Okay, and this array is public, so I can check for this as well. So let me write this in counter spec only. So here I'll write one spec. Let me calculate, copy this, and let me paste it, and here check for say India. So here I'll say counter dot, the array name I'll give. Okay, counter dot countries. Okay, const values. So this itself is an array of countries, and here it will check const value and contains. Okay, to contain, to contain. Okay, and here I'll check for India whether it contains India or not. So it contains India, so the test should pass. So let's check it, let it get executed and we can check it. Okay, so this way we can even check for the string as well, whether that string contains this particular word or not, Okay, so this is saying test passed. So if I come over here, I see that the test for this has passed. Okay, check for India has passed. Okay, check for India, it has passed. So if you click on this link also, then it will give you the details, spec details. Okay, now if I check for say China, so China is not there in that array, so it will fail. Okay, so let us execute it. So it watches for the change and it automatically re-executes. Okay, so this has failed. Why it has failed? So if you come over here, you see. Okay, now click on this hyperlink. Okay, so anyway, it is showing you the stack there only in the first screen. So even after clicking, it is not showing in your browser. You can click it and it will bring you to this error console. Okay, so that is how we can check whether a particular code is valid or not, means the output is valid or not, it is as per the requirement or not, as per the expected behavior or not. So this way we can check for the test, check for the validation of the code, whatever code we have written, we can check for the validation of the expected behavior. Okay, so this time we give Japan, so Japan is there, so it should pass. So it is success. Okay, so this way there are many more APIs to try out for within this, so you can just try it out. So this was just an introductory session or a handholding session to give you an idea of how to write a automated testing for Angular app, Angular 2 or Angular 4 app. So hope you liked this session, and many more sessions to come up in different technology stack. So thanks for watching my video, and bye bye, have a great day.